This is the continuity tester kit with all the parts soldered on. It's now ready to be installed into the tin. So what I'm going to do is just go through the installation process so you can get a kind of feel for how you can do that. I'm going to be using this much smaller tin, although with the kit I'm going to supply the larger tin, but I wanted to show how that will go into a smaller tin. So what we've got here is the actual board itself, obviously, as I've just shown you. We've also got the piezo speaker, so that's going to be installed into the tin, and then also with that we've got a uh, a battery clip. So the tin itself we need to drill that and just prepare that for the actual kit. So the first thing we want to do is mask tape all the areas that we want to drill holes through. So you can see there's the battery clip terminal, the two probe holes, and so what we're going to do now is just drill through each of those holes, including the speaker holes at the back there, which you saw. So you can just do this quite easily. It's very pliable material, so it's easy to drill and saw through it, and it's quite easy material to work with. So these tins are very soft, pliable, taking off all the burred edges. That ensures that when we put our cables through the holes, the battery clip cable and the two probe cables, that they don't get cut up by the holes. So that's really what we're doing here. We're just smoothing out those holes, making sure that everything's nice and clear of burrs and edges. And that's it really. That's that done. So now we've got the other two holes have already done there, so they're ready to go. The only holes that haven't quite finished it yet are the speaker holes, but I won't be going through how you do those. Quite obvious, just the same process really with the speaker holes. So there we have the all the holes drilled and all the cables now ready to be soldered up. So you've got the board there. You can just see the red and black leads and the yellow and orange leads ready to be soldered up to the cables. Uh, the piezo speaker there is ready to go, and so that's the whole thing. That's how you can install that board inside that small tin. So this is the finished item now. I've used one of the small. In fact, I've used the smallest tin that comes with these kits, but the kits that will be sent out actually will come with this much larger tin. The reason I put it in this size tin is just to show you that you can get these kits inside very small tins. So this is the smallest tin you'd probably want to go to. I supply these, so if you wanted to have a small tin for this continuity tester, then you could just order that as an extra. But this tin here comes with it anyway, so there's a lot more room in here. For example, inside the circuit in here, I've used just these leads as kind of headers, so they're more flexible. But you could actually use these kind of headers for the connections here. So I've got, like, on this particular kit, I've got three main connections. I've got the power lead, I've got the probes here, which these are the probes, and then inside there's also the leads to the speakers. But each one of those leads could actually just be a pair, some headers like this. But I've decided to use leads because it gives me more flexibility. But you can use anything you like, really. So anyway, let's just show you quickly the inside of this. So these are the probes. I'll just undo the probes here. They're very simple. I haven't done anything complicated here. I've used just normal stiff hookup wire for this. I just find it easier. I mean, these are, personally, I think it's nicer because you can bend these, and they're actually very strong. I mean, and of course, you can bend them anywhere you like. So I like those, as unlike probes, which are normal kind of probes, like on your multimeter. These kind of probes, although they're very flexible, they just flop around. Whereas, so that's the reason I've done that. Although looks a bit odd, it actually works quite well. So let me just open this and show you how I've mechanically how I've secured those leads. Now I don't know how well you can see the inside of that. Let's just bring it up a bit closer. Now I've used these very standard wire connectors here, there and there. Now that's really just to give it more mechanical strength, and you can glue those to the bottom of this, and then of course any pulling on the wires out here, I haven't glued anything here at the moment, but if you can imagine that was glued, then any pulling here, and also you'll notice I've tied, I'm not sure if you can see, but inside I've actually tied the wires, and I've tied them on the outside. So if you glued that down as well, and the same with the power lead here at the other end, if you can see that, on here is the power lead block, and if you glued that block down as well, then the mechanical strength is, well, there's no way you could pull that out. So that gives you a lot of strength. The other leads just go to the speakers, so there's no stress on those anyway. So that's really the inside. So you can see the printed circuit board is down in this area. I've insulated the bottom of the tin with electrician's black tape here, so that stops anything shorting out against the tin. And that's it really. There's the little speaker. I've used a piezo speaker on here, so I've connected up a piezo speaker, as you can see down to here, and that's it. So you can see it's you know, there's not a lot of room in there, to be honest, but there's actually more room than it might appear. That was actually quite easy to put together. So with the 3 holes drilled on each end, those 2 holes and that hole, that's it. That's the finished item. The other nice thing I like to do with these projects is always have the power. I mean, a lot of people like to have the battery inside the enclosure, but you know, for these small projects I think it's better to have the battery on the outside. So I've drilled hole there for the speaker so you can hear the speaker better. And in this case, the other thing I like to do is to connect up the battery. So let me just do that. So if I connect up the battery, and then when I'm using it, I just use some standard elastic bands. So for example, if we just elasticate that, it's actually very easy to do. That keeps everything in place, believe it or not, you know, because this tin is not very heavy, so a couple of elastic bands, I mean, it might seem a bit makeshift, but basically that's as good as you want. So you've got a continuity tester now, and like I said before, that will pick up different resistances. So there's no continuity on that. So let's just test it on a screwdriver. I know there's. So you can see there's a total short there, so that shows there's continuity. So that's it really. So you can see that's a very simple, nice effective tin. You can place that anywhere you like, and then when you finish with it, you can either leave it. I mean, the nice thing with using batteries like this, I use rechargeable ones, is if you've got several little projects on the go, you can just swap the battery between them. You know, there's no need to have the battery on here all the time. So, you know, if you want to use the battery for another project, you can just quickly whip it off, leave the elastic band on there, and then you've still got your continuity tester. So I actually prefer that way of doing it. I mean, with the larger tin, you could use a 9-volt battery, and you could probably, for example, if I show you because you'll be getting the larger tin, if you wanted to, it's entirely up to you. These larger tins will actually house a 9-volt battery, so you could have your 9-volt battery in there. You can have it either way. You can mount it like that, or you can mount it here. So really that's the advantage of this bigger tin. If you really wanted to have a battery inside, you can see that this whole circuit basically would go on that one end, so you get all the circuit work there, or you could even have a lot bigger circuit here and have your battery on that end. So that's quite useful. You can keep your batteries in this size tin. So you'll get this tin with the kit, in case you do want to do that. But I didn't want to do that. I just wanted to show you how you could fit these in a very small tin like this, and then you can just simply, as I said before, you can connect up your batteries like that. Now I think that's a really good way of doing things. Other people might think it's a bit makeshift, but I think that works really well. So that's that kit completely built, from PCB board, soldering up to finished item.